The thing I love about XAML is its power, number one. Okay, so there's a lot you can do with XAML. I like the fact that it's XML. I like the fact that it's structured the same way that HTML is. The way you work with it is the same way that early people worked with HTML. Like in the early days of HTML, what did you have? Notepad, right? There was no Dreamweaver, there was no Go Live, there was no front page. There was Notepad and there was HTML. And there's just something about that that I think is very pure and very good. You can type something in, run it in Longhorn, just double-click on it like you double-click on an HTML file, and then boom, up comes the result. Or, you know, an error if you made an error. But the idea is that it's simple enough to work with and simple enough to comprehend, where if you're used to working with tags and you've got that web background, you can get your feet wet in XAML really quickly. And because it's XML, and because it's a tag-based format, you can pretty much read it and understand what's going on. One of the things that I find very difficult about working with other traditional programming languages, whether it's C# or Visual Basic, is that the code can be spread out all over the place, and if you don't know where to start reading, you can get lost really quickly. Depending on how the program is structured, sometimes things are happening in threads, and sometimes the things are happening in background tasks, and sometimes you've got code hidden deals, and you have no idea. It's like, okay, the code could be, there, it could be here, whatever it's doing. I like XAML because it's straightforward. Okay. It's straightforward. It's something where I can look at it and I can say, yes, I understand this, I understand that. It lends itself well to blocking things out in an organizational fashion, whether it's styles or, layout, whatever. So I like its power. I like the fact that it's tag-based. I like the fact that it's easy enough to get your feet wet doing something useful. Like this is what, a 30, if even that, 20-line example, right. And it's doing something that's actually kind of cool, reading data and flowing it. Another example I wanted to come up with was trying to get some interactivity in the using some data binding. Can I come up with a UI that that responds to user changes with no script? So here's an example of a UI, right, that I built using XAML. And this button down here is a regular button, and up here are all the controls that operate on it. So, for example, this text string here, if I just start typing in new text, you can see that the button text is changing in real time, right? And then if I change the font size, I can make the font size bigger and smaller in real time. All of these things, I can just change the color. I can change the opacity so it fades in and out. If I don't like the font, I'll just make, I'll change the font to like Verdana or something. You can see as I type a valid font name, it just changes to the right thing, right? So, oops. Edit that part out. Right.
Hey,
so.
There's a reason Longhorn isn't shipping.
Exactly, right. Exactly. So if I type in, let me see, yeah. So anyway, you get the idea, right? Yeah. So as I type it, but again, there's no C# code for this. To do something like this in the past, you'd have to like write some event handlers, right, to like respond to the fact that I'm changing the slider and then change the font size. But if you look at the code for this, it's all just straight XAML code. And let me just make the font a little bit bigger so we can read it a little bit easier. But here's all the controls up here, right, in this dock panel, and all these different. And the way it all works is here's the button definition, and you can see that everything is just bound to the other elements up there in the UI. There's no script code controlling this at all. It's just all pure XAML. And if you looked at the way things were done in the past like this, I'd have to say, okay, when this slider changes, for example, I would write some kind of event handler function that would get called whenever the slider changed. And then in response to the change, I'd get the value of the control and then poke that value into the font size for the button or whatever. And in XAML, you don't have to do that. It's just straightforward binding operation. So it uses data binding not just for reading data, but for actually building a UI, building an interactive UI. So these are the kinds. This is where Longhorn really just takes UI development, to the next level.
Now, if you're a standard old app,
mm-hmm.
what does this mean?
What do you mean if you're a standard old app? Like,
well, if you're
first of all, you continue to work. That's one very important thing.
Right.
But the idea is that let's take a look at the way apps are developed today, right? And typically, what happens is development teams go to the designers, says, "Design me a UI." Okay. Designer goes and sits down with his favorite design tool, whether it's Photoshop, whether it's Illustrator, whatever it is, right? Draws up this big, beautiful, mocked-up UI, goes back to the developer team, and says, here's the UI I've got for you. Now the developer has to say, all right, now I have to somehow duplicate this Photoshop-drawn thing in my Windows program. And maybe he can do it, maybe he can't. You know, there's some things that a designer is going to come up with that Windows doesn't have a control for. Or if there is a control for it, now I've got to do some owner-drawn mess to get it to work. XAML takes that problem and basically eliminates it, because all of the drawing stuff that you would do in a vector program like Freehand or Illustrator or whatever, you can just do that same kind of vector operations in XAML, define your styles, and then the designer just gives the finished UI to the developer, who then hooks up the finished logic. So it removes it makes the designer a first-class member of the developer team. It's no longer somebody who just draws things and then maybe they get used, maybe they don't. The designer can actually draw the UI for the application, draw all the styles, draw the interface, give it to the developers, and the developers can take that exact XAML code and then just hook up the back-end logic. So if you've got some kind of drawing program, whatever it is in the future, that puts out XAML or takes some other format and converts it into XAML, you've got the UI for your application. You know, the developers don't have to reduplicate it. They just hook up the logic and they're done. Yeah, that's going to be a real significant productivity step.
That's sort of how they did the clock.
Yeah, so for example, the clock could be the clock is a great example of that. This little clock up here is drawn, and you can notice that since it's all vectors, it grows and shrinks when I make it bigger and smaller. At least it's supposed to. I don't know if it does in this version of Longhorn, but yeah, this clock is a great example. This interface is all drawn using vectors in XAML, and the logic that makes this little guy spin around is probably just a couple of lines of C# code just to get the time or whatever, and just move these hands to the right direction based on what the time is. But everything else in there, even the shading, all the tick marks you see, all of these are just XAML elements. So a designer could sit down, draw the clock interface, draw the hands, draw the second ticker, and just give it to a developer and say, here's the clock interface. Now you write the code that just moves the hands.
How does that compare to other operating systems? In other operating systems, you have to use a C-like language.
Yeah, pretty much. And it's well, in other operating systems or just WinForms, when you look at it today in Windows, the idea is that it's all programmatically done. Even when you're using an advanced interface builder application, where you have your little drag and drop buttons and stuff, you're still working with underlying code, but to get any kind of interactivity to actually happen between the user interface elements, you got to dive into coding.
This is a new paradigm for programming.
It's a new paradigm for programming. It takes what people have done in other tag-based languages like like HTML or XUL or whatever, and applies it to the Windows interface. The difference, and this is one of the things that always irritates me about people when they see XAML and they compare it to things like Zool or whatever. XAML is not just a user interface language. You can represent any kind of Windows object as a XAML tag. So even if it has nothing to do with the UI, it's a way of representing just generic Windows classes, not just.
Do you have an example of that?
Like, well, the XML data source is a good example, right? The XML data source tag is not a UI thing. It's an actual object in it's an actual class object in Windows, C# or whatever, and it's not even though it's not a UI thing. I just declare the class as an XML data source, give it some parameters in XAML, and it goes and does its thing behind the scenes. It handles the binding, it handles the filling of the data set, the data collection. All of that's taken care of, but it's not a UI thing, right? It's not a button, it's not a slider. It's a class that I've instantiated in XAML, and it's built to be extensible. So if Joe, decide to come up with Joe's control set, and I want to ship it out to people and say, here, use my wonderful controls I've come up with. I define the styles in XAML. I define whatever code I have to define to make other things work. I package up as a DLL, and then I can say, here are the XAML tags that you should use. And I'll make some namespace like Joe, and then Joe : my super button, or Joe : my super control, and then anybody can just build that right into their XAML.